In this example, we have been asked to describe the end behavior of each of the following graphs by drawing a picture. I'm going to refer back to the prior video where we were basically finding out which direction the ends pointed, and it's based on the leading term. Notice that for each of these examples, the leading term is actually first. So each one of these has the leading term as the first term, and the other powers are written in descending order. If that's not the case, you need to make sure that you write your function in descending order first. For the part A, we're first going to look and see what the power is on the x. The power here is even. That means that the end behavior is going to be both ends going the same direction. Then we look in the front and see what the coefficient is. This coefficient is positive. So the end behavior of this particular graph would be both ends going up. The next one over, part B, we notice that the exponent is odd, and then we understand that there'd be a positive understood 1 in the front. Being odd means that the ends are going to go in opposite directions. Being positive means the right end goes up, the left end goes down. The next one, we notice that we have an odd exponent here, and we have a negative number in the front. Okay, it being odd means that the ends go in different directions. It being negative in front means that the left-hand side is the one that goes up, and then the other end goes down. And then finally, the last one, we have an even exponent here, and then we have a negative in the front. The even exponent tells me that the ends would go the same direction. The negative tells me that the direction would be both down. Now this is interesting because all we looked at was the very first or leading term of each one of these examples. The rest of this doesn't make any difference to the end behavior of my graph. The rest of it determines what happens in the middle, but the end behavior is not affected by the rest of the polynomial.